we're going to cover another aspect of circles today called sector area. And in addition to that, that's not a huge topic, we're also going to talk about general area problems and how you solve them. Okay, to start with, I'm going to define a sector. So a sector is a portion or section of a circle. So let me draw a picture. And generally the sectors we talk about we'll start at the center of the circle and go out like this. This is right here, a sector. In this circle, this would be the radius. So this is the center. And this here, this angle here, we're going to call theta, which is the same notation we used when we were using arc length. And here's the center, so I'll just call that O. We're going to find the area of this sector. But to start with, you have to recall that the area of a circle is simply pi r squared. So if I want a section of the circle, I'll do the same thing that we did when we talked about arc length, which is I'll take a fraction of 360 degrees to get it. In this case, theta, say if that was 30 degrees, I take theta over 360 times the area. So what that means is if I had, for example, this is, as I said, 30 degrees, this would be 30 over 360, or roughly 1/12 of the area of the circle. If I had this to be 90, I'd get a quarter. 90 over 360 is a quarter. 90 degrees, I'll draw 90 in here. That would be 1/4 of the circle. So this would become 1/4. If I want this to become this actual circle formula, all I have to do is put 360 in here. And I get 360 over 360, which is 1. So I just get the circle formula back. Okay, before we do a couple problems on this, why is this useful? This would be, for example, I don't know, you want to find the area of a pizza slice that you're taking out of a pizza, or a cake slice. Anytime you want to find a fraction of a circle, you take a circle and divide it into parts. Okay, so now let me give some examples of that. I'm going to write the formula back up here. Okay. I'm going to draw a circle. Here's the center. Put a little piece in here. I'm going to call this 45 degrees. And I'm going to make the radius 18 yards. Now I want to find what the area of this very, very large slice of pizza is. So what I do is I take the formula. I take theta, which is 45 degrees, divide that by 360, and then multiply that by pi 18 squared. So I'm just going to put that in my calculator. 45 divided by 360, which is 1/8 basically of a circle, times second pi times 18 squared. And I get 127.2 yards squared. Okay, before I give you a couple problems to do yourselves, just notice this is exactly very similar to the formula you had for arc length. So I'm going to write that up here as well. That was theta over 360 times 2 pi r. So this is a fraction of the area, and this is a fraction of the circumference of the circle, which is the total distance around it. Okay, so I'm going to give you a problem now. So again, this is the center. That's a right angle, and I'm going to make the radius 16 centimeters. And I want you to find this area. Okay, pause the video here and try to solve that problem. Okay, if you're back, the area of the sector is 90 degrees over 360 times pi 16 squared, which is, just to check your answer, 201.1 square centimeters. Don't forget the units, it's area. Okay, we'll do one more. Okay, another circle. Make it a little more complicated. This time I want you to find the area of the large part of the sector here. Okay, pause the video, try that. Okay, if you got an answer, This time, my area is 360 minus 30 is the angle I'm dealing with, 330 degrees. Divided by 360 degrees times pi. Oop, I didn't give you a radius. Sorry. Probably noticed that. 5 meters. Let's make it 5 meters. Pause that again if you didn't get it there, and now try it again. Okay, if you're back, that's 5 squared. Sorry about that. 330 divided by 360 times second pi 25. 72 square meters. Okay, pretty straightforward concept. We're now going to do more general area problems, and I'll embed some sector problems into them. So I'll leave this up here. Okay, so there are two methods for doing general area problems. I'll leave that up there. And we've done some of these in the various homeworks we've had. The first is called the addition method. And I'll give an example, which I'll do in a moment. Okay, so the addition method is when you have more than one basic shape put together. So for example, in this case, I want to find the area of this upside down very large ice cream cone, which consists of two pieces, a triangle at the top and a half circle at the bottom, which uses the sector area idea. So why is it called the addition method? What you do is you find the area of the triangle, and then you add the area of the half circle. So let me do that problem, and then I'll talk about the other method. So the area of the triangle is 1/2 base times height. Base is 8 feet, height is 7 feet. So this is half of 56, or 28 feet squared. The area of the half circle, there's a whole half circle there for you, is equal to 180 degrees divided by 360, which is a half, or I could just think of it as a half, but this is where that comes from. 1/2 times pi r squared, and r in this case is not 8 feet, but rather 4 feet squared. So in other words, pi times 0.5 or half times 16, or 25.1 square feet. Okay, then the area total, this is how the addition method gets its name. You add it. So you just take that 25.1 and you add it to 28. And that gives you 53.1 feet squared total for the entire upside down ice cream cone. So again, that's called the addition method. You break it into fundamental shapes, which we can find the area of, and then you add them up. Okay, now I'm going to show you the subtraction method. Okay, subtraction method, I'm going to put example down. I'm going to put a square here, 10 inches by 10 inches. And out of it, I'm going to take some circles, 4 circles, poorly drawn. They're supposed to be next to each other, right? And each of those circles has a radius of 2 inches. Oops, 2 inches, 2 inches, 2 inches. There we go. And I want to find the area of the non-circle part of it. Okay, so this is a little different than the one before. We don't have an area of a square, and then we're adding the areas of the circles. We're actually taking the circles out and putting a giant hole punch through them in 4 places. So what we want to actually do is find the area of the square, and then subtract the area of the circles. Hence the name subtraction method. So in this case, the area total will be the area of the square minus the area of the 4 circles, like that. So this is what you do when you have a hole in something. The other one is what you do when you're appending shapes together. So in this case, the area of the square is 10 times 10 inches squared, and the area of the 4 circles is 4 times one of the areas of each of the circles, which is just pi 2 squared. So that's 100, and 4 pi 2 squared is 50.3 square inches. And then I just subtract them, and that gives me 49.7 square inches total. Okay, so those are the two main methods. I'm going to give you a problem to work on now. See if you can come up with this. I am going to give you I'm going to give you an addition problem to work on. So here we go. Oops, that's supposed to be rectangular. Okay, you can assume the top part is a half circle. The height from here to here is 12 feet. And across the bottom is 8 feet. Okay. So I want you to try to find this area of this giant, looks like a tombstone really. I'll pause the video there. Okay, if you're back, it is made up of two shapes. You have to break it up yourself, but there's a rectangle on the bottom and there's again a half circle. So the area of the tombstone total is simply the area of the rectangle, which is 8 times 12, plus the area of the half circle, which again is a half, sector area half, 180 over 360, times pi, and the radius is not 8 feet, but rather 4 squared. Or this is 96 plus, and I can't really do the pi numbers in my head, 25.1, same as the last one actually, feet squared, which is, what is that, 121.1 square feet total. Okay, that's an example of an addition problem. Now we're going to do a subtraction problem. Okay, I've got a big plate here. Not a big plate, it's like 5 centimeters by 5 centimeters square. Now out of that, we're going to take a little window on the inside of it, which is 1 centimeter by 4 centimeters. And I want you to find the area around here, not including the hole. Okay, pause the video, try that. Okay, if you're back, the area of this area total will be the area of the square minus the area of the rectangle. Area of the square is 5 times 5. Area of the rectangle is 4 times 1. Don't need a calculator for this one. That's just 25 minus 4, or 21 square centimeters. And again, that's the subtraction method. Okay, now we're going to do a couple problems that will use the sector area ideas as well. So I'm going to draw a circle, and then I'm going to draw another circle inside it. And then we're going to take a sector out of the whole thing. So this is the center of the whole circle. Like that. And I need a radius. We'll call the radius this 5 centimeters from here to here. And this will be another 3 centimeters from there to there. And this will be 60 degrees. And I want to find the area of this portion of a ring. Okay, so what do we do? First of all, it's got both the idea of the sector area in it, because we're not taking the whole circle, and it's got the idea of a subtraction in it, because we are taking out the middle part from a total. So there's a couple ways you can think about this. I'm actually going to calculate the outer sector, assuming this is filled in, and then subtract the inner one. So the area of the outer is the angle, first of all, which is 360 minus 60, or 300 degrees over 360, times pi r squared. Now r is not 3. You might immediately jump to thinking it's 3, because that is not the radius of anything, it's just the width of the ring. The radius is actually from here to here, or 8 centimeters. So I'll put 8 in there, squared. And that's the area of my outer that part there. I'll get a number for that. It is 300 divided by 360 times pi 64. 167.6 square centimeters. That's assuming now, that number assumes this is filled in, but it's not filled in. There's a hole in the middle. So I have to take the area of the inner part, which is also still 300 degrees, divided by 360. The only thing that changes is the radius. The radius of the inside part here is 5. So that's 5 squared. So now let me calculate that one. That is 65.4. Yes, 5.4, I'll round it. Centimeters squared. Okay, now I want to find the area of the ring. I just do the area of the ring is the area of the outer minus the area of the inner, which looks like it is 102.2 centimeters squared. Okay, we'll try one more. I'll try one more. So in this case, I'm going to make a big circle, and inside of it, I'm going to make a smaller circle, and another smaller, oops, that's too big. Another smaller circle over here. It was 2 eyes, giant alien. And this distance from here to here is 4 inches. And what I want to find the area of is this eyelid and the rest of the head. But not that, or that. You can assume, by the way, this is 4 inches as well. In other words, this is the radius of the big circle. Okay, why don't you pause there and try it, and I'll come back and work through it with you. Okay, if you're back, first thing we do is find the area of the outer circle, or just the area of the circle, big circle. Call it area of big circle. That will be just pi radius squared, which in this case is 4. Pi 4 squared, or that's 16 pi. I'll get numbers as I go along. I think that's, yeah, 50.3 square inches. Okay, now we have to subtract out a circle, this circle and half of this circle. So the area of the, what do we want to call this, the right circle, is just going to be pi, and not 4 squared, but rather 2 squared. 4 pi, 12.6 inches squared. And the area of the left half circle, again, now we can use the angle here is 180, so it's 180 over 360, which is a half, or you can just say it's a half, times pi 2 squared again, and that's just going to be half of that number, 6.3 inches squared. Okay, then the area total is going to be the area of the big circle, which is 50.3, minus this area of the right circle, which is 12.6, minus this half circle on the other side, which is 6.3. And that will be a total of 31.4 inches squared. Okay, so that's it. I'm going to go through homework in a moment, but for just a summary, sector, finding a portion of a circle that starts from the center, you just do a very similar thing to arc length, which is you create a fraction, the angle, the central angle over 360, times the area of the circle itself. If you want to find a more general area problem, there are 2 methods. There's the addition method, which is just if you have, for example, I don't know, a circle, and then you say have another circle on top of it. You can find the area of this just by taking area of the circle, area of that circle, and adding them. Or you can do the subtraction method, which means you've got a hole in some of your figures. Again, you still need fundamentally basic figures which you can find the area of. But if you do that, you find the area of the whole thing, and then subtract out the holes, which again, hopefully are fundamental shapes. Okay, for homework, for geometry, there is a sector area worksheet to do. For advanced geo, there is the same worksheet, plus a couple of challenge problems. Page 665, 45, and 46, and some SAT problems, 51 through 54, on that same page. All right, thanks. Until next time.